Hey everyone, Carlos here from the Hydra team. In this short intro video, I'd like to step you through using Hydra to build Node microservices. But first, what is Hydra? Hydra is a NodeJS module which facilitates building distributed applications such as microservices. Hydra does that by addressing distributed computing concerns so you won't have to. Here is a list of features that Hydra offers. Don't worry if this list looks daunting. You get to decide which features your application needs, and you can simply ignore the remaining ones. We'll approach this intro from the perspective of an Express.js developer. Don't worry if you use or prefer another framework. This introduction will still serve as an overview for using Hydra with your Node framework of choice. To keep with our Express.js perspective, we'll look at HydraExpress, a Node module that uses Hydra core and Express.js bindings. As its name implies, HydraExpress is designed for Express.js developers. Again, if you're using a framework other than Express.js, you can still use Hydra core instead. In order to make this clearer, let's examine a block diagram showing your application and its relationship with Express.js, HydraExpress, and Hydra. The outer box represents your application. Your app requires HydraExpress, which already contains Express.js and Hydra core inside. Your app can still ask HydraExpress for Express.js and Hydra core using these handy HydraExpress methods. So your application will still have full access to both libraries. If you'd like to follow along and try the code samples, then you should already be familiar with Node and building Express.js applications. If not, don't worry. This intro will still give you an overview of what's possible and might even inspire you to learn more. However, you will need access to a Redis server. What's Redis, you ask? Redis is an in-memory database, which is often used as a caching and messaging server. Redis is hugely popular among developers, so chances are good that you or your organization are already using it. If you're familiar with Redis, then you're good to go. If not, check out my Redis Quick Start video, which will show you various ways to get a hold of Redis. For now, you can just follow along, as you really don't need to know how to use Redis in order to use Hydra. So let's get started. Let's begin by first reviewing how to build an Express.js app. The point of this review is to later compare it to how we would do this and more using HydraExpress. The Express.js site offers the following minimalistic Hello World application. The application is meant to illustrate the most basic concepts. Your app must require Express. You define routes using Express. Your app listens on an HTTP port. And you can do all of that using just a few lines of code. Naturally, you wouldn't want to make this the basis for your production level application, but it is easy on the eyes and helps to illustrate key concepts. Let's create a sample project using this small program. I'll create a Hydra demo folder for use with this tutorial. For the npm init step, I'll name the app index and just press through the defaults. We can see that a package.json file was created. Next, we'll install Express with a -- save option so it gets added to our package.json file. Now let's add the Express code to the index.js file. We can run this application using Node index.js and access it from a web browser using HTTP localhost port 3000. So this works as expected. Let's install HydraExpress and update our Express app. If we look at the package.json file, we can see that we have Express and Flywheel Sports HydraExpress as dependencies. We don't really need the Express entry because HydraExpress already includes Express.js. Feel free to remove it from your own projects. To interact with our app, we'll also install Hydra CLI, a command line program for interacting with Hydra-enabled applications. Because Hydra is designed to facilitate distributed computing, you'll need more than one Hydra-enabled app or service to see anything useful. Now we're ready to modify our basic Express app to use Hydra-Express instead. As you can see, this code is only slightly larger than our basic Express app. First, we add a require statement for Hydra-Express. Then we also require a config JSON file. We'll have a look at that shortly. We also define a function called onRegisterRoutes, which will be called when Hydra-Express is ready to register our routes. At the bottom of the code, we initialize Hydra-Express using the config we required and also pass our onRegisterRoutes handler. In the onRegisterRoutes handler, we ask Hydra-Express for a reference to Express.js and use that to create a router for our API. We register our new API endpoint under the route prefix of empty string. After requiring Hydra-Express, it needs to be initialized using its init call, which accepts an object representing configuration settings. Let's see what we need to add into this file. As you can see, this configuration file contains a single branch called Hydra, which contains fields describing our Hydra-enabled service. The service name field names our service. This is an important field which will allow other Hydra-enabled services to find our hello service. There's also a branch for Redis, which contains the connection info for our Redis instance. In this case, we're running Redis locally. The DB field contains a Redis database number. We'll use DB15, but you can typically use any number under 16. There are some exceptions here. On free tiers of hosted Redis services, such as Redis Labs, you only get one DB, DB number 0, so you'll be forced to use that one. Excellent, so let's continue. We'll use ES6 in our demos, so let's update the sample code accordingly. This isn't a Hydra-Express requirement, just something we prefer. So other than the use of the let keyword and arrow functions, the code is pretty much the same as what we had earlier. Let's run this small program. We immediately get back some information, such as the service name and port. If we access this app via the web browser, we'll see the exact same output as our earlier Express app. So that's not at all impressive. Let's change the app slightly to make this a bit more interesting. First, we obtain a reference to Hydra Core. As I mentioned earlier, Hydra-Express includes Hydra Core and Express.js. So we can access all of the underlying power of both Hydra and Express. In our route handler, we'll send back a response that includes a service name. In our case, that's hello service. And we'll also return the service instance ID. The service instance ID is a unique identifier which is assigned to each service. Now if we run and access our app from the browser, we see something like this. The service name is useful as we can have a collection of services communicate via service name without having to worry about IP addresses and ports. The service ID is useful in that we can differentiate multiple service instances with the same name, but more on that later. Now let's see how we can interact with other Hydra features using the Hydra CLI client we downloaded earlier. Hydra CLI allows us to do quite a bit. Just type Hydra CLI to see the options. To set up Hydra CLI for use, we have to tell it where Redis can be reached. Since we have Redis installed and running locally, we can just use the default values. Note that we're using Redis DB15 above to avoid conflicting with data you may already have in your Redis instance. You can use any number under 16, but all of your services should use the same number if they're going to work with one another. The Hydra CLI nodes command lists registered service instances. We currently only have one service running, but we can see that it's called hello service. We can also see the service ID and other useful information. Another really interesting thing we can do is ask Hydra CLI for a list of known routes. Now what if we want to see the health status of our running services? We can do that using the health command. So let's review what we're seeing. The Hydra CLI client demonstrates that our simple hello service is emitting presence and health information, as well as routing information. We also saw how we can reference our service by name rather than IP address and port. Let's do something really interesting now. Let's stop our hello service and edit the config.json file. Change the service port value from 3000 to 0. What that does is instruct Hydra to randomly choose a service port. This will allow us to run multiple hello service instances on the same machine using different ports. With the config file updated, start an instance of the hello service in a terminal tab. You should see that the service is running on a different port. Now if you open another terminal shell and start another instance of the hello service, you should see it running on another port. Running the Hydra CLI with the nodes command confirms that we are indeed running two instances. We can actually use Hydra CLI to call one of the hello service root endpoints. If you issue the Hydra CLI call a few times, you'll see that you get a response from the other running service. Note that the service IDs are different. So you probably guessed that the calls to the hello service are being load balanced. Again, also note that we're making RESTful calls to the service by name only. So what if we wanted to speak directly to one of the running instances? Say the instance with this first ID. We can do that by modifying our call through the Hydra CLI. Now, if we repeat the call a few more times, we only get responses from that service and the request isn't load balanced. Really cool, huh? Let's try something else. What if one of our services dies? Well, that's easy. Let's just stop one of them. Now let's call the service a few more times. Notice that we only get responses for the instance that's still alive. The use of the Hydra CLI client is just an easy way of demonstrating the power of Hydra. All of the functionality inside the Hydra CLI is really just the underlying capabilities of the Hydra NPM package. So the same power is available to your own Hydra-enabled microservices. Now imagine that you have a collection of microservices and imagine that they're able to communicate with each other without regard for where they're located. Even if an instance of your application dies, other instances will be able to continue to receive requests. This demonstration is only the very tip of the iceberg. Hydra offers much more than we can cover in this brief tutorial. There is one last thing I'd like to demo before we wrap this up. Express.js has an Express application generator. Here's how we can install it. To generate an Express app, we simply enter. That saves us from having to type a lot of boilerplate code to set up a more useful application shell. The good news is that Hydra Express also has a similar tool that can generate a variety of microservice templates. Let's install the Hydra app generator. In this demo, we're going to use the Hydra app generator to build two microservices which can speak to one another. We'll use the generator to create our first service. Let's call the first service Red. We'll step through most of the defaults. The only field that isn't optional is the service name. Let's see what was created. So that's neat. The generator created a project complete with a README file, a folder for our config.json file, a folder for our API routes, and even a folder for our unit tests. The nice thing is that all of those are placeholders, and we can ignore them until we need to fill them in with code. So the code that got generated is slightly different from our earlier simplistic example. The reason is that this version is built to scale as your application grows. An important change we can see is in the red service.js file. We can see that our route was defined using a route prefix. In this case, it's the /v1/red portion. The reason for this is to help us organize routes and is also helpful in advanced routing, which we won't cover here, but if you're interested in, you can check out our Hydra router project on GitHub. Let's look at the route file that got generated at Redis service routes Redis v1 routes.js. We'll modify it to return a new result. That's similar to our earlier examples. Let's build the project's dependencies and run it. Now let's switch to another shell and create a service called Blue and make the same one-line change. And let's run it. We can manually call the two services using Hydra CLI. Note that we're using v1red and v1blue prefixes to access the routes. Now what if we wanted each service to be able to communicate with the other service? Let's look at having the red service speak to the blue service. The Hydra module has a makeAPIRequest member function. Let's look at how that works. Here we have a handler that is invoked when the red service initializes. We can see that the only thing that happens here is a console log is issued to output the service information. Let's add a bit more code into this section of the service. First, we ask Hydra-Express for a reference to the Hydra core object. We then use a Hydra method called createUMFMessage. This call creates a universal message format message. So what does that mean? UMF is a JSON object format which is used to describe a message that can be sent through and between distributed applications. Think of it as a common language between Hydra services. Notice that we pass the createUMFMessage call a single parameter, which is a JavaScript object with to, from, and body fields. There are other fields we can add, but those are the minimum required fields. The body field contains the actual thing we want to send to another service, while the to field specifies the path to the service we're interested in speaking with. The format of the to field is rather specific. First, we specify the name of the service we'd like to speak with. Next, we specify the HTTP method type of the message. That is like get, post, put, and delete. We place the HTTP method inside square brackets. And lastly, we provide the route path we want to call. That's the v1 blue route. There are a few really cool things about this. For starters, we didn't have to specify the IP address or port of the blue service. In this demo, the blue service is running on our machine, but it could be anywhere in the world that is network accessible. That works because of Hydra's built-in service discovery methods. The next cool thing is that we get to specify the HTTP method type, so we can use this to call any HTTP service API, whether that's our own services or Twitter's or Google's public APIs. The last thing is that we simply add the path to the route we're interested in accessing. Together, this simple format makes our message completely routable. So creating a UMF message is pretty easy once you understand the use of these three basic fields. Now we're ready to dispatch this message using the Hydra makeAPIRequest call. When the call resolves, the handler specified in the then call is invoked with a response object. We simply log the response to the console. Let's run this and see it in action. Keep in mind that you'll need to ensure that the blue service is running. Otherwise, you'll get a 404 not found response message. So when we run the red service, we'll see something like this. That's a response from the blue service. We see a status code of 200, which is HTTP OK. The status message field says OK, and the status description says the request succeeded without an error. Then we see a result field, which contains the actual response from the blue service. It's the familiar message format we've seen in this video. That's pretty cool, huh? Using this simple code, you can build all sorts of microservices which easily and effortlessly communicate with one another. And there's an even easier way to communicate among services using Hydra's send message call. That's beyond the scope of this basic introduction to Hydra, but we'll delve into it in future videos. So we've seen that building a basic Express.js app is fairly easy, and that building a Hydra Express app is not that much more code. What we get for adding very little code is a great deal more functionality than Express.js gives us out of the box. We saw that even a basic Hydra Express app emits health and presence information. We saw that our apps and their routes are discoverable. We even saw that calls are automatically load balanced when more than one service type is running. We used Hydra's generator tool to quickly build a microservice project and saw how the Hydra CLI tool can be used to test our services. Lastly, we learned about messaging in Hydra using UMF and the makeAPIRequest call. And there's really much more I'd like to share. In future videos, we'll delve into more of what Hydra has to offer. In the meantime, check out our Hydra repos at github.com/flywheelsports. Thanks for watching.